what we started last class is trying to teach you guys on how do we estimate the cut and fill. We will go for, my first, we need 2 hours more. So we will go for 6 hours on how to find the cut and fill manual. Then we will also have a civil 3D training, which will go for about 4 hours on how to do the cut and fill using civil 3D. In the last lecture, we started our discussion about earthworks, and our first example was about how to find the cut and fill for a project like a sewer. What makes the sewer different from other project is the sides of the excavation are vertical. So we can estimate the volume from a profile. And you can see here in this slide here, I do have my profile. And the way we do it is we figure out the side area. And once we figure out the side area, we simply have to extrude it and multiply it by the width of the excavation. Remember, in this view here, you don't see the width of the excavation because the width of the excavation, it is just perpendicular to my view. Okay. Now, when it comes to the side area, we figure out we have two methods. In my slide here, we have two methods. The two methods are, we have a trapezoidal rule or Simpson rule. The trapezoidal rule, the assumption is the ground has sharp changes, while the Simpson rule, it assumes a smooth ground, and we discussed this last class. Remember that each method, it has some conditions to apply. Okay, you need to verify the condition or the condition. Here we go. I'm going to quickly remind you without going into deeper details, the condition for trapezoid here. One condition, which is the space is not. What can we do if the distance is not constant? We have example for that. The other methods, or sorry, before we go to the other method, the rule is very simple. The side area would be the interval, which is constant, divided by 2. And then you have two terms here. The first term is this depth of cut is repeated twice in the calculations. So plus 2 multiplied by the sum of all the depth of cut, not including the first and the last. So in between all the other depth of cut. Now the Simpson rule, which it assumes a smooth ground. It has two conditions, and the two conditions are same as trapezoidal. We need to have a constant interval. Students, the typical pay attention to, which is the cut or 5 or 7 or 9 and so on and so forth. Once you have those conditions happening, then here is how you estimate the side area. So you start here with x, which is constant, divided by 3, and then you multiply by 3 terms. One is the first plus last, and so plus. When I say even, I'm not referring to the value, not the value of the depth of cut, rather than its count. So depth number 2, depth number 4, depth number 6, and so on. And then finally, plus 2 multiplied by the sum of all the odd depths, you must exclude the first and the last, which means we start from number 3, number 5, number 7. We stop before we hit the last depth of cut. So in our last class, Don't forget what we're getting here from either or trapezoidal is a side area. Don't forget that we must multiply to get the volume for our project. Now let's look at this example here where the conditions of
Hey, Tahir, I
trapezoidal
think you're lagging.
or Simpson. So guys, here is the point. We over the city, and not only myself, like we had the discussion this morning with other instructors. So over the city, everybody's at home and everybody is my problem, and there is nothing we can do about it. All I can do, probably I can move to my place, just sit next to my router. We can do that certainly, but just give me a moment. We'll try to see what can I do. Okay, give me a couple of minutes, please. So can I ask you, do you hear me better right now?
Yeah, I do hear you better now. It last time would come and go though. You would sound good and then you'd sound bad. But right now
Yeah.
it sounds
So
good.
as I said, thank you, Ryan, for bringing my attention to that. But I can tell you, it is minus probably 50 outside. Everybody's at home. Everybody's off. Everybody's using internet. So there is a high pressure on the network, not only in my house, but it's all over the city. Instructor this morning, they had a discussion where everybody's saying, I have a slow internet, slow internet. That's something that we don't like, but there's nothing I think we can do. Will do my best again. Please feel free if along the way you just don't hear me, feel free please to notify me, and I will try to repeat as much as I can. Okay, so let's go back to our discussion where we were at this point here. So really, this discussion is about what if the distance which we refer as x is not constant. And here we go. We're looking at the same example. However, the only difference is I'm going to circle it here. So this is the only difference. The only difference is this, and this number will make a difference. Why is that? Because look at the spacing. So you can see here we have a spacing of 25 meter, 25, 25, 25. However, the last one is not 25. So what can we do? The answer is very simple, and some of you maybe already have some idea on what to do. So the thing is, we have to stop where the condition is not there. So you can see I am going to say I cannot find the total side area in one shot. I cannot. Why? Because this last spacing here is 30 meters. Okay, I will label it so everyone can see it. So between this line to this line, this distance is 30 meter, which is simply different from anything else. So how we do it is we stop here. We go ahead and stop here. Why do we stop at this point? Because this is where the conditions are met here between the 0 and 125. And so we kind of a split. We'll circle it here, which is from 0 to 125. Then I will try to find the SA2, which is the smaller side area between 125 and 155. And then finally, what you do is you add them together, and then you get the total side area. Then you multiply it by the width of the excavation, where you can find the volume. I'm asking you guys, do you think the idea is clear so far? Are you following so far? I need some confirmation, please.
Yes.
Yes.
Okay, thank you. So here is how we do it. As I said, use the method wherever the conditions are met. We can see obviously in the last segment conditions or the condition is not met, then we stop at 125. Watch this, please. So when we do the estimate from S for SA1, and remember what is SA1? It is the side area from 0 to 125. So here is how we do it. First of all, where is my constant? Here we go. So here is your 25 over 2. And then you have a big term that includes two smaller terms inside. One is first depth of cut. Where do I get this number? I'm going to connect it to here. Huh? So this number goes here. The 1.9, that is your first depth of cut. Now here is the tricky part. The tricky part is when we estimate the side area from 0 to 125, the 2.85 is not, look at this. So I'm not going to take this 2.85 like before, place it here, rather than taking the 2.35. Because remember, the side area right now, it is between 0 to 125. So your last depth of cut is the depth of cut at 125. Then very simple, plus 2 multiplied by the sum of everything in between. You can see I boxed them for you guys out. So all you have to do is you add all in between, starting from 2.4 plus 2.8 plus 1.93 plus 1.85. So this is will get you the side area from 0 to 125. Now finally, how can we find the SA2? And let's zoom into SA2. Look at this. So here is SA2, and SA2 is simply a trapezoidal shape, a little trapezium, okay? And remember, although we have a method called the trapezoidal method, but you guys know where this method originated, okay? It is coming from the fact that we're adding those small trapezium as per the discussion we had last class, okay? So can anybody help me just by looking at the table? What should be the area of this trapezoidal shape? Not super science. Any help?
30 divided by 2 multiply 2.35 plus 2.85.
Thank you so much. I will say it a little bit different. Only what you said is right, but I will say it differently. Huh? So what you do is we get the average between the depth of cut here and depth of cut here. Average, it means we add, divide by 2. So 2.35 plus 2.85 divided by 2, then finally multiply by the height, which is 30 meter. Thank you so much. And here we go. So now we have SA1, SA2. Next is we add SA1 plus SA2, and this will give us the total side area. Don't forget that I have to multiply my side area by the width of the excavation to get the volume. Okay, now let's move on to what happens if I want to find or solve the same problem using Simpson method. Using Simpson method. Okay, now for Simpson method, I need to remind you we have two conditions, and both of them they have to happen before you start the calculation. Let's check. Can we estimate the side area between 0 to 155 in one shot using Simpson? Please help me.
No.
No, and the reason why no is that same thing, the 30 is different, so we don't have the constant interval. So we will try to do the same as we've done here. So if we go one step backward and we try to say, can we find the side area from 0 to this point here, same as we have done for the previous method? Let's check. Now, when you check, you will see, oh, 25, 25, 25, 25, 25, ever. When you start counting how many depth of cut we have, you will see here is 1. So here is 1, and then 2, and then 3, and then 4, and then 5, and then 6. And what does it mean, 6? It means we have an even depth of cut. Remember, 6 is an even number, which means no, you cannot, because the condition requires an odd depth, odd number. So here is the answer. The answer is we have to stop here. So when we stop here, so we go one step backward. Look at this. So I'm going to remove this guy from my estimate, and you can see, let's count 1, 2, 3, 4, and 5. And the spacing is 25 meters from 0 to 100. And that's why we can use Simpson here. So from 0 to 100, we can use Simpson, and then we later on we will figure out a trapezoidal shape, and then also we figure SA3, which is another trapezoidal shape. Let's do it. Okay. Now here we go. Here is the side area. We will be SA1 plus 2 plus 3, where we can estimate SA1 using Simpson. Why? Because X is constant and the N is 5, which is odd. Now here is a tricky part. The first is 1.9. I'll take my arrow and I will point to here. So here is my 1.9. This is the first depth of cut. Now the tricky part is the last one. The last one, which one is the last one? Should I use 2.85 here as the last? No, because the A1 goes from 0 to 100, which means the last, it should be at 100, which is 1.85. Okay. Now, plus 2 multiplied by the sum of the odd, not including first and the last. Remember, this number 1, number 2, number 3, number 4, number 5. So which one is really the odd but not including first plus last? It is this guy here. So watch this. So the 2.8 goes here, which is number 3. Because 1 already went here and number 5 went here. So this is number 3. And then finally, plus 4 multiplied by the sum of all the even depth of cut. And remember, not the value. It is the count, which means number 2. Watch this. So here is my number 2, which is even. I'll take this one here. And here is number 4, which is 1.93. That's number 4. It goes here. Okay. Now you have estimated the side area from 0 to 100. The side area from 100 to 125 is so simple. Okay. It is very simple. It is 1.85 plus 2.35 divided by 2, and then finally multiply by the height, which is in this case, any help? How much this distance?
25.
25. So 1.8 again one more time. So SA2 would be 1.85 plus 2.35 divided by 2. So you get an average, and then finally multiply by 25. How about SA3? SA3 is the same as the previous example. So we say 2.35, which is here. So we take those, we get an average in between, then finally multiply by this distance, which is simply a 30 meter. How did I get the 30 meter? Look at the station. So that's 155, and this one is 125. So this distance is 30 meters. You add the 3 numbers together, you put line here, you add the 3 numbers together. This will give you the total side area from 0 to 155. Then don't forget to multiply by the width of the excavation, which is, I think if I remember correctly, it is 1.75. That is the total width of the excavation from the cross section. Watch this. It's here. So we found the side area, and this will be the width of the excavation here. Any questions so far? Any questions so far?
Yes, Taher. If we have a smooth soil surface, we should be using Simpson rule. But if we have even numbers, do we have to apply the same method that you just showed us?
You're confused, okay? So you're confused. So can you please mute yourself? So you're confused because simply there is no relationship between first of all, the logic, you have to look at the soil. When you look at the soil and you see the soil is smooth, I mean, it has curvature, then you say, you know what, I will use Simpson, because we know Simpson, it has an assumption of parabola. Number two, you look at the conditions of Simpson. It needs a constant interval and an odd number of depth of cut. And if it's odd number, great, good news. We can use it same as we've done early, like last class. And if it's not an odd number, then we do some little tricks like what we've done today. And by the way, so you know, there is no way for you to use Simpson here. Okay. So for example, some will ask, okay, you're between 100 and 105. You know, nothing you can do. Okay. You must use trapezoidal in here, and that's the best you can do. Did I answer the question, or I make more confused?
No, it's okay, thanks.
Okay, anyway, so if you are not sure, just meet me after the class. I have time afternoon. Okay, so now we simply move from the sewer. You can see we've done the sewer so far, and we move to another example, and you will see quite difference between the first one and the next one for a good reason. So let me in this example here, we simply need to build a little section of the road. The road length is 150 meter. The road width is 8 meters. The road elevation at the start is 111.1, and the road slopes up by 1%, and the side slope is 1:1. I need you to remember that this information, you cannot think about it as unknown. Those are the design information, whether the length or the width of the road or the side slope, all those are outside the surveying. We get them from someone else. And that's why, whether in the assignment or in the midterm exam, all the information will be given to you. Will be given to you. Now, next is we need to look at the survey data. The survey data here, we have a very similar numbers are the existing ground elevation measured using total elevation, for example, and they are measured every distance, which is 25 meters. Look at the numbers. So we have 25, 25, 25 before the shape of the crown. Now, this will make a huge difference between the first and the second example. This is unlike building a sewer. And really the difference is the side slope. Watch this. So I'm going to show you here. Here we have a side slope on each side, 1:1. In the previous example, it was vertical side of excavation, because we have a shoring and we have a bracing. And here for roads, we don't do that, because in roads we have here, like if you want to maintain the soil vertically, you have to build here a retaining wall and here a retaining wall. Okay, and this is something we don't do it because it's going to be super expensive. We do it only at the entrance of a bridge. So if you're going on a bridge, typically we have a retaining wall on each side, and we simply have no side slope. But in general, roads are built with a side slope because soil cannot naturally retain itself vertically. So why this is going to make a big difference between the first method and the second method, I'm going to share with you guys. To show you to show you my point and prove my point, let's try to turn this into 3D. A line here to make a little 3D for the problem. So here we have a slope like so, and okay. Now I'm asking you guys, what if you get the side area? Like, let's say we will follow the same method. So we draw a profile, and then from the profile we find the depth of cut, which is on this picture here. This number here is your depth of fill. Sorry, not depth of cut, it is depth of fill. And let's say for simplicity, let's say this is 1 meter. Let's say this is 1 meter. And then you're gonna go ahead and for the next section after, let's say 25 meter, you're going to say, you know what? I'm going to also find here my depth of cut or fill. Let's change line type. Okay. I'm hoping that I'm doing something that it's not confusing. Just how you understand better. So we have another section, and this section is happening after 25 meters. So this is 20. Let's say this is 25 meters. Okay. Now we want to go ahead and say, okay, let's do the same as the last problem. So we say, some of you will say, let's find the side area. So let's find the side area. So we take the 1.1 and then the 1.2 and so on and so forth. And then we find the side area. I want to try to my best to I'll do this, and I will probably have to rotate a little bit. I don't think I have the right tool here, but so I'm not to confuse you. I will get rid of this one. So the side area is here. The side area is between this line and also this from here to there, and then from here to there. Okay. Probably I will change the colors of the 4 lines so you guys can see better. So the line, I'm going to make it, let's say, blue. Just please be patient. I'm trying to make a good sketch for you so you guys can follow me. Okay, so here is another blue line. And then this is the last one. Okay, last one. So I want you to imagine if I go ahead and do the same exactly like what I have done in the last problem by taking the 1 and 1.2 and all other depth of fill and put them into Simpson or trapezoidal. What happens is I will get this area, side area. Let me ask you, can I multiply the side area by the width of the road and I get the volume?
No.
No, you can't. I want everyone to believe what I think you're Mona, I guess. Or do you guys like agree with Sana that if I take the area of this blue rectangle and I multiply it by the width of the road, I'm not really getting the volume that I need to build this road. And why is this? Is because simply if I do so, I'm simply ignoring this volume here, and I'm also ignoring this volume here. Okay, because the assumption here, it looks like I'm assuming that we have a vertical size of cut. Okay, if you find the side area and then multiply the side area times the width of the road, which is 8 meters, what you're doing is you're ignoring the volume here and the volume there, which is not correct. So I'm going to show you right now on how to do that. Please watch me. So the way we solve this problem is we draw the profile, and I will not spend any time to show you how do we draw the profile. We have existing ground here, and we have the road and with the slope of the road. And simply we are not going to find the side area. These numbers are coming from surveying. We have the existing ground elevation every 25 meters, and simply we have the road elevation at the start. Let me ask you, anybody in the class still cannot find the elevation on the road every 25 meters? I remember what you are given. You are given the slope, the elevation of the road, which is here, the elevation of the road at the start, together with the long low, but we don't know the 5 meter like here and there and there and so on. I'm asking you, anybody in the class cannot find this yellow, like the numbers below the yellow rectangle? Okay, if you can, please say yes, I can do that. This is simple.
Yes.
Okay, so I'm gonna have the assumption again. If you cannot, don't be shy. Let me know. I can repeat one more time. But I'm gonna have the assumption that yes, all of you are able to fill the table and know what is the road elevation every 25 meter or every given distance. So I'm able to find all those elevations from which we can find, same as last class. Okay, sure. For example, let's see, how can we find this number here? So, okay, so I'm going to hide this number and I will show you how to find the number. Okay, so the number is, you want to start from 110.11. So this number is 110.11, and this number is the road elevation at the start. And then the road has a slope of 1% up. And because it's 1% up, watch this, plus, because the slope is up, and then 1, and then divided by 100. Why divided by 100? Because it's not 1, it's 1%. So every 100 meter, we have gain in elevation of 1 meter. And then finally, multiply it by the distance, which is in this case 25 meter. Okay? Why 25 meter? Look at this. It is simply this distance here, 25 meters. Okay? Because we know the elevation here and we don't know the elevation here. So the distance 25 meter. For the next point, for example, if I want to estimate this number here, if I want to estimate this number, then the distance, everything will stay the same. However, this number here will be 50 meter, not 25. Okay, so I'm going to move this one to here. So this one will be 50, and this is how you estimate this elevation here, and this is how you estimate this elevation here. Are you following?
Yes.
Okay, so I'm going to clean up again, and so to continue. And so once you finish and build or finished all the numbers under road elevation, your next step is the same as we have done with the last problem. What you have to do is you need to find the depth of fill. Okay, you need to find depth of fill. And remember, before we said cut, here it's fill. Look at the cross section. I'm asking you, this one here is cut or fill?
Fill.
This one is fill. Why? Because simply we always start from the ground and we build our road up or down. If we need to build our road up like so, it means we have to add layer of soil to build my road. If the situation is the opposite, it means my ground is up and my road is down. So then we have to cut to come to the road elevation. So this is called fill. But it doesn't matter. The calculation will stay the same. It's just a matter of changing the name on the table. So let me remind you, how do we find the point 8? Any help? Can anybody tell me how do we find the point 8, which is the depth of fill?
Yeah, subtract the exist ground from the road, or opposite of the road from exist.
Exactly. So look at this. So simply it is shown here. So where is depth of fill? It's C. This C is the depth of fill, which is very simple. It is the road elevation minus the existing ground elevation. Okay. So this is the depth of fill. We do it here and we repeat the same thing over and over and over until we finish and fill all the table. Remember, in this example here, I'm showing an example where the road stays above the ground all the way. So please look at the blue and look at the magenta. It means the entire volume is fill. If there is an intersection between the blue and the magenta, like let's say, for example, this, let's say this was my road. It means my road sometimes was below the ground. So in this case, this area will be cut and then later on will be filled. I have a problem here on our slides, but not now. I'm going to take you gradually from easy to a little bit harder. So please, for now, let's think about only if I have everything cut or everything fill, no change. Next, I think after the break, I have an example where it changes from cut to fill cut, but doesn't matter. Okay. So far, what we've done, we're able to fill all this line here. So we're able to fill this part in the table, which is road elevation. We're able also to find what is my depth of fill for the entire problem. Then finally, we will have to find something. We, in the previous problem where we built the sewer, we simply took all these numbers, and what we did is we put them in trapezoidal or Simpson to find the side area. Once you have a side slope, please take a note, you cannot do that. If you have a side slope, you cannot take the depth of fill or cut and find side area. Don't do that. So what do? We estimate a cross-section area. And I know some of you, oh, what do you mean? What is cross-section area and what side area? Let me show you here. The blue, this blue here is called side area. So I'm going to write it here for you guys. So this is called side area, SA. Okay. So where is the cross-section area? It's here. It is the area of the cross-section. So this will be cross-section area. And I'm asking you, what do you think about the cross-section area? What is the shape? Is it rectangle, square, trapezoidal? What is the shape of this guy here?
Rectangle and two triangles.
Exactly, it's a rectangle plus two triangle, or you can say this one is trapezoidal shape. This one here, if I clean it up for you, if I clean it up a little bit for you, you will see this one here is simply a trapezoidal shape. If you agree, huh? So we need to find the trapezoidal area. That's how we estimate the cross-section area. Okay, I know some of you will say, Tahir, okay, yeah, it is very simple. It is simply a rectangle, like Sana said. So this rectangle here, so we take this rectangle and let's say color it with the yellow, and then plus this those small rectangle, triangle on the side. I'll give you the vision here, and you guys can verify it later on. Huh? So the cross-section area, is equal to W multiplied by C. Now I'm asking you, if I multiply W times C, the width of the road times the depth of the fill, I'm asking you, what do we get? W multiplied by C, we simply get the yellow hatch, huh? So we get the area of the rectangle. How about the area of the triangle? Watch this, plus Z multiplied by C to the power 2, okay? And I know some of you will struggle a little bit until you figure it out. This is simply the area of the two triangles on the side, and I'm going to show you what do they mean. C is still the same. Huh? C is the depth of Z is the side slope. Z is the side slope, and we have a little discussion about it later on. But for now, watch this. So what you have to do is you should be able to find the cross-section area at every given section. Now, what is the method? Sorry, what is the rule? Rule is here. Okay. So I give you here a little cross-section where the road width is W and the depth of fill is C, and the side slope is Z units horizontal to 1 unit vertical. Z units horizontal to 1 vertical. So the vertical will always be 1. And there is a reason for that. Because if you turn your slope into Z to 1, if this dimension here is C, if this dimension here is C, from here to there, if this is C, it means the horizontal side of your triangle is very simple. You take the C, you multiply by the z, then this will be the base. And look at this. If the height is c and the base is c times z times c, so what is the area of this triangle? Half base times height. Half base times height. And what does it mean? It means half times z times c times c. So half z c squared. And if you have 2 and it's identical from the similarity, then what happens is this whole two triangles will be z c squared. And we end up with this equation here. Remember, you don't have to memorize the equation. You just have to know how to use it. Where all you have to do is know what it means. W, it means road width will be, and the C is the depth of fill from your table. And then finally, the Z is the side slope. But it has to be Z to 1. Z to 1. I think I have here some example for you. Now, what happens if my line goes 1 unit horizontal and 1 unit vertical? How much is my Z? The Z is equal to 1. Z is equal to 1. If my side slope, let's say that's my side slope, and it's 1 to 1, like let's say here, this will be a 1 unit, and this is a 1 unit. So this is 1, and this one here is 1. So in this case, your Z is ready right away, because always you have to make sure that the vertical is 1. If the vertical is 1, so this number will be your Z. So 1 to 1, it means the Z is equal to 1. How about if my numbers are 3 to 2? This number is 3 and this number is 2. Okay, this number is 2. Any help? How much is my Z? Always you have to make sure that the vertical is 1. How to do that? You divide this by 2, you divide this by 2, which will give you 1.5 to 1. So this will be 1.5 to 1. So if you are given a slope 3 to 2, it means your Z is 1.5. How about finally, how about if this guy here, is equal to 1 and this guy here is equal to 2? Any help?
0.5.
Exactly. So what you have to do, always. Because in this equation here, it says here Z horizontal units to 1 vertical units. If it's 1, great. So you have the Z already. If the vertical is not 1, make sure it's 1 and get your Z. Let's go to our example and apply it right away, and you will see how easy is that. Let's go to the cross section first. I'm asking you, how much is my Z here?
1.
1. Great. So now we know, remember this, my Z is equal to 1, and it's typically constant, so the side slope will stay constant, I guess, as long as the soil is the same, because 1 to 1, it depends on the soil type. Okay, so 1. So remember, Z is 1. And let me show you how do we find this number. So I'm going to hide it here, and we're trying to figure out how much this is. Very simple. Watch this. So I'm going to go here and say area at 0. Why area at 0? Because we're estimating the cross-section area at station 0. Remember how the road went, the example? Okay, if you cannot remember, it's easy. Go here, look at the cross section. How much is my W? How much is the road width? 8 meters. Okay. So what you have to do here, you come here and say, okay, my W is equal to 8, multiply it by the C. Can anybody look at the table and find for me how much is my C? And remember, C is the depth of fill.
0.8.
0.8, correct. And then plus, this will give you the area of the rectangle. I'm still missing the 2 triangle on the side. So plus, how much is my Z?
1.
1. And then finally multiply by the C squared. the C to the power 2. So the C is 0.8, and I'm going to do that to the power 8. I don't have here a nice like a tool to write equations. So guys, remember, we use always this one for square, huh? So this is 0.8. And what you get is, you will get here a 7 point something. And you take this number, you simply place it here. Okay, and this will be your 7.04. Let's do it at 100, let's say, let's say the area at 100, which is here. So I'm focusing here on this section right now, this section. So let's do it one more time. I'll double click here. So I'm trying to find the area at section 100. So your W is still the same, which is 0.8. How about the C? Anybody can help me with the C from the table?
2.05.
2.25, and then the Z stays the same. The Z, which is side slope, stays 1. What to do is repeat this several times until you fill the cross-section area in your table here. And then we're heading to our last step, where we're going to find the volume. And then we take a break, if you're curious when the break is. So the break is coming very, very soon. So remember, we're able to figure out all these numbers. So we are able to find the area here, and the area over there, and the area over there. Okay, I want you guys to remember two numbers, because this helps us to understand the method. 7.04 and then 5.62. I'll go to here and 0.04 meter square. So that's the area at section 0. And then the area here, the next one is 5.62. So write it here. So we know the cross section area is 5.62 meter square. Okay. You know what? I'll just clean a little bit so you guys can see better. I will remove the SA because we know that it's wrong. We're not estimating the SA. We're not doing this. We're not doing this. Okay. Now I need some help. Anybody can think of a simple method not to find the volume for the entire road. No. Only the little volume between 0. So this is the section at 0. So here we have 0 plus 0, 0, 0. And then this section here is section at 0 plus 25. Anyone can come up with a very simple method to find the volume in between only 0 and 25, nothing more, Don't go further, just between 0 and 25.
Find the average of the two cross-sectional areas.
Exactly, sir. Thank you so much. So please watch this. I'm going to type in something, and please let me know if you agree. I'm going to say V1 because I'm not really estimating total volume. I'm estimating partial volume. So this would be same idea, will be 7.04 plus 5.62 and then divide by 2. What's missing is I need to multiply times
25.
25. Thank you so much. Now I'm going to expand the discussion a little bit further. What if, remember, I know that also the area at 50, which is here, 5.16. So on this picture here, you know what? I'm going to write only the area. So the area here at 50, this is 5.16. So after 25 meter, so I'm going to copy and paste this guy. We'll take it here. So section, which is 50 meter station, the cross-section area is 5.16. Can anybody tell me if you want to find the volume, not the entire volume, but the volume between 25 and 50? Any help? I'm going to call it V2. I need the volume between 25 and 50. 25 and 50. Any help?
Average 25 and 50.
Yes, sir. So yeah, so it's 5.62 plus 5.16 divided by 2 multiplied by 25. And you can see, I'm hoping that you guys are getting the idea. Does this remind you on the trapezoidal method? Like we've done this already, but not on the areas. We've done this on the depth of cut before. You can see How much? How many times 5.62 will show? Look at this. One time here, another time here. Okay. I'm asking you, how many times you think 7.04 will show?
One time.
One time. Does it remind you with trapezoidal? It's exactly the same idea. We have here a common factor, which is 25/2. That's common factor. And there are some numbers will repeat only once, which is the first and the last area. And there are some numbers will repeat twice, anything in between. I need you guys to agree if you think that what I'm saying is right.
Yes.
Okay, so here we go. We're going to the last step. We're trying to figure out what is the area. What is the area? So the area here is so simple. I give you here the example where we estimated the area at 0 and area at 100. Once you know all the areas, then we can apply trapezoidal method to find the volume right away. And how we do that, watch this. But don't forget that prior to any calculation, I want to make sure that my x is constant. Is that true? Yes, it's true. Because when you look at the table, you will see the spacing or the station, everything is 25. It means, yes, I can apply trapezoidal. And watch this. So when you look at the trapezoidal, so this one will be your common factor, your x divided by 2. And then we have a big bracket that contains two small brackets. The first one, which is multiplied by 1, what do you think? What are those areas? This is the first area, 7.04, and this one is the last area, which is 19.4. Let's look at the table. When you look at the table, the 19.4 is your last area. How about the rest? Is going to be, remember, every area in between the first and the last, it will repeat twice in your calculation. And you can see, because it's twice, you need to multiply by 2. What are those numbers? Look at the table. Those numbers are simply all areas between the first and the last. I will box them out. Okay? I will draw here a box between for these numbers. So we need to sum 5.2 plus 5.16 plus 17.87 and so on and so forth, but don't include the first and the last. And this is how we find the volume. Now, the tricky part is, I'm asking you, do we have to multiply anything here by the width of the excavation? Like what we've done, like when we have a vertical side of excavation, we found the side area, and then it is an area in meter square, and then we have to multiply it by the width of the excavation. I'm asking you here, to get the volume, do I have to do anything else?
No.
No, because simply you're multiplying cross-section areas in a way multiplied by distance, so no need to do anything else. Okay, and so we're able to figure the volume right away. Now, I think we can do the Simpson before the break. So same idea, guys, like same as we apply trapezoidal, we can apply Simpson, and it depends on the shape of the ground. So all you have to do is look at this line here in reality. So if this line tends to be broken, sharp edges, we use trapezoidal. How about if this line here is a smooth line? So we can use Simpson. And very, very straightforward. Here is how we use Simpson. Remember, before you use Simpson, you must check two conditions prior to any calculations, which is number one is, do I have a constant interval? Yes, it's 25, so it's okay. Now, do I have an odd number of areas? You need to count the areas, and if you count them, if you take your time and count them, you will see 1, 2, 3, all the way to 7. So 7 is an odd number. It means yes, we can simply use Simpson right away to find the volume. How? Watch this. So you can see here, I'm going to say my distance, the constant over 3, and then I have big bracket that contains 1, 2, and then 3 terms. 1 is multiplied by 1, which is the first area, plus last area, and then 2 multiplied by the sum of all the odd area, not including the first and the last, which means number 3 and number 5. Because 1 and 7 already taken. Remember this number 1 and this number 7. So this will be number 3 and this will be number 5. And then finally 4 multiplied by the sum of all the even areas, which is number 2, number 4, and number 6. And so this is how we find the volume. Any questions so far before we give you 10 minutes break? Let's see.
Can we just get a couple practice questions just to run through?
Sure, go ahead. Ryan, what's your question?
Can you hear me now?
No, now I do, yeah.
Is there a couple practice questions that we can run through? Like that you have a print off or something?
I can simply change the numbers, those numbers to any numbers, and I can give it to you. Yeah, and so certainly over the reading week, I can do that.
Okay, awesome.
Okay, so any other questions? We will have a 10 minutes break, so I will see you guys here at 11:07, please. Thank you.